Well, hey there, modern math teacher. I gotta be real with you guys. Can I admit something for a second? Like, straight, no cap. There are so many math concepts that I taught for years that I honestly didn't really truly understand myself, right? Like, I can do them and I could teach the procedure, I could explain the steps, I could get students to get the correct answers. But deep conceptual understanding, absolutely not. Just none of that was happening here, right? And honestly, like that happened for more topics than I would like to admit because I have taught a full range of classes throughout my years. But that all really changed for me this year in a big way because this year, as I've mentioned, I'm working towards board certification. I'm working with a new curriculum, and I've spent more time really thinking intentionally about my own math understanding. And I realize how many things that I had originally just memorized instead of truly made sense of. And you guys, I know I'm not alone in that. Okay. So text me on the show. Tell me what are some of the concepts that you have taught just because you knew them procedurally, but you don't actually deeply understand. I know I'm not alone in this. I'm gonna share mine with you today. You share yours with me via text, okay? All right, you guys. Hey, hey, everybody. Welcome back to the Modern Math Teacher Podcast. I'm Kristen Moore. I'm your host here. And today we're going to talk about the math concepts that I finally understand more. Maybe not 100, but I understand them more as a math teacher. Why that deep conceptual understanding matters so much and how relearning math has actually made me a stronger teacher. So if you're up for it, let's do this. Now, I think a lot of us became successful math students because we were really good at memorizing procedures, right? And like, honestly, that worked for a long time. You learn the steps, the formulas, the shortcuts. And if you're really good at following patterns and picking up on those things, you can do really well in math, right? You can be a great math student. But teaching math, that's different because when your students ask you why, you need to be able to say something other than, well, because the rule says so. That's only going to get you so far with your students. So let's explore one of the ones that like broke my brain, okay? So one of the biggest examples for me this year that we just wrapped up teaching was function transformations. And specifically, I'm talking about any of the horizontal transformations because if you look at them, they feel backwards. If you're moving right, you're using a minus. If you're stretching horizontally, but you're multiplying by a half, right? And so for years, including parts of this year, I taught those very procedurally. And I would say, well, your exes, just like in real life, in algebra, they're crazy, right? And they just do the opposite thing. But that's not teaching. It's a good way for them to remember, like, oh, yeah, that's right. We did this deep exploration to figure out why to move right, I have to subtract because I'm actually just trying to match the same output that I initially would have had. And so because I'm shifting the input, I need to inverse what I'm doing there. Like, just blew my mind this year, okay? Right? This year, I spent so much more time trying to really understand why things like this happen. And what finally started helping me was thinking about it, like I just said, as those inputs and those outputs. If I want the same output at a different location, then you have to use that inverse operation on the input, right? And suddenly I was like, input has an inverse, or input needs the inverse operation to get the exact same output that we started with. And that's when it just started like clicking for me. But I can't say that to a student and have that make sense to them, right? Like I mean, even just explaining it to you guys right here on the podcast right now. If you want the same output at a different location, you have to use the inverse operation on the input. What does that mean to you, right? But when I got it, right? So I don't know how I'm going to explain this better to my students. That is my goal for this year. I finally understand it deeply enough to be able to really help my students deeply understand that as well, right? And working through that discomfort as a teacher, you guys, that has made me so much more empathetic towards my students because I realized, oh, like this actually is conceptually difficult to understand. Not because my students, aren't smart but because like genuinely those underlying mathematic algebraic ideas were pretty abstract and it's pretty difficult to cope with that. So, function transformations, just one of the things that I deeply or more deeply understand, and I'm still working to explain. So, if you have a really great explanation for your students, like, I'm using the illustrative math curriculum, so we've got really good conceptual and problem solving things going on there. But if you want to help me out with my consolidation of that and help me teach them a little bit better, that would be key. Text me, tell me that. Okay. Another thing was the evolution of the number system. That was big for me this year. I never appreciated that as a student, but like every single time we've entered into a new problem that we couldn't solve, we had to invent a new number, right? Like, so we could count all of the all of the apples that we're trading, right? Or we can count all the Apple iPhones that we're trading. I don't know, you know what I'm saying. But then what do you have if there's nothing? So then you need a zero, right? And then what do you say when you owe somebody something, right? And so then we invented integers, and we got negatives, and then we had to take an area and we had to divide it into parts, and so we invented fractions, and then we got these irrational numbers and these complex numbers, and every step was basically saying, okay, well, the system should hold, but it's broken. What do I do next, right? And that makes the math story feel so much more human. So instead of saying like these are fixed rules handed down from above, it becomes much more like people have been trying to make sense of problems forever, and as they've encountered these situations where they were unsure, this is what they decided on, and we've gone from there. And so just having that understanding completely changes the way I teach it. I used to just teach it as like, I don't know, here's a graphic organizer, guys, let's do something with it, here's how they expand, and this is what it includes. But now we have a story to the context, and it makes it so much more humanizing. Okay. So the deeper that my understanding became throughout this year, the more intentional my instruction became, which was really great for my students and for me. Because now I wasn't just thinking like, how do I teach students how to do this? I started asking, what are the misconceptions that make sense here? What prior knowledge really matters that I need to draw on? And because I've taught all the different classes, I can pull out a lot of that, right? And what are those ideas that my students are building towards later? And again, I know that because I've taught up and down the high school spectrum. And honestly, like that has been what's helped me so much, because when you can see where your students are, where they came from and where they're headed, you start seeing math as one connected story instead of isolated units or topics. Even though we do, algebra, geometry, algebra 2, which I still love integrated math. So shout out to everybody who gets to use an integrated math program. I'm jealous. But I do really enjoy being able to teach all the different contents so that I can pull from those. It's really great. So honestly though, I really do think that every teacher should spend some time studying above and below their grade level. If you haven't taught those courses, just study a little bit above and below your grade level. Not because you need to become an expert in everything. I'm not saying that, right? But because if you can understand the bigger mathematical picture, it's going to change your instruction. Okay, it's going to help you activate prior knowledge better, prioritize important ideas, and explain future relevance more authentically to your students. And it makes teaching more intellectually and energizing and engaging for you, right? Because you're not just delivering content, you are the lead explorer as you are exploring mathematics. So let's see. Other topics that I had to learn more deeply about this year: logarithms. My girl Mary says logs are exponents, and the way that she gets it, it's just always popping in her head. Her kids always understand logarithms better than everybody else. So shout out to Mary. And I get that. I get that logs are exponents, but I didn't get it until this year when I was teaching with this curriculum. And I was like, oh. When you have those moments and you're just like, man, that is when it all clicked for me. And so I could see the relationship between the log rules, which I used to literally just memorize and teach kids and teach them to memorize them. That was it. I could see the actual relationship between the log rules and the exponent rules. And we all know how much sense the exponent rules make and how we simplify those. And so making those connections and parallels, just like mind-blowing again. Okay. So what is that? That's 3, I think, for me this year. The number system, transformation of functions, and logarithms. If you've got another topic that you think we should all better understand to teach it better, let me know. Shout it out. Share it in an email, text it to the podcast, whatever you want to do, right? All right, you guys. So bringing it back, I think this year reminded me that teachers are learners too. And that's a really good thing because the more deeply we learn and understand and appreciate mathematics, the more thoughtfully we can help students make sense of it too. And I don't think teaching gets weaker when we admit that we're still learning. I think it gets stronger. So, if you're trying to think more intentionally about meaningful learning experiences, projects, and helping students truly to make sense of mathematics, I've got a free guide that can help you. And if you want to read along with us for our July math therapy book study, you can grab the book at the link in the show notes. All right, you guys, that's it for this one. Again, I want to know, what concepts did you not understand? Just like me. All right, guys. Until next time, keep it real.